In this video, we will learn if there is a differential equation which is not linear, how to reduce that non-linear equation to a linear form. Okay. So this method is known as especially this format of the differential equation is known as Bernoulli's equation. Okay. So the format is dy dx plus dy equals to q into y to the power n. This n is basically, it can be any integer. N is belongs to z, and we already discussed that this p and q, they are basically function of x, or it can be constant also. Okay. So we can rewrite this equation in the form of y to the power minus n dy dx plus p into y to the power 1 minus n equals to q. Okay, this is our equation 1. Now, in this equation, if we consider y to the power 1 minus n equals to z, and if we differentiate this equation with respect to x, it will be dz equals to 1 minus n y to the power n minus n dy dx. Okay, so we can write that y to the power minus n dy dx equals to 1 by 1 minus n dz dx. Okay, so in the equation 1, if we put the value of y to the power minus n dx, so it will be 1 by 1 minus n dz dx plus p z equals to q. So now we can write this equation in the form of dz dx plus p into 1 minus n z equals to q 1 minus n. Now this equation also can be written as dz dx plus p dash x, this is basically function of x, z equals to q dash x. Okay, where p dash x is nothing but 1 minus n p of x, and q dash x is 1 minus n q of x. Okay, so therefore this equation, we can say this equation is a linear equation. Okay, this equation is linear. Okay, in z. So therefore our integrating factor will be e to the power 1 minus n integration p dx, and the general solution will be z into integrating factor equals to integration q dash x into integrating factor dx plus c. Okay, so in this way we solve this type of problem. Okay, so try to understand this method with an example. Okay, suppose in the first example, the given differential equation is x square y to the power 3 plus 2xy dy equals to dx. Okay, so we can rewrite this equation in the form of dx dy minus 2y x equals to y cube x square. Okay, so there is one thing that I want to mention here, that in previous example, each and every equation is in the form of dy dx plus p of y, sorry, not p of y, p into y equals to q. Here p and q are function of x. Okay, so here the integrating factor is e to the power integration p of x dx. Okay, but if the given differential equation is in the form of dx dy plus p of y x equals to q of y, so definitely in this case our integrating factor will be e to the power integration p of y dy. Okay, now come back to this problem. So we can write this differential equation in the form of 1 by x square dx dy minus 1 by x 2y equals to y cube. So this equation is not linear, definitely. So we have to make this linear equation first, linear differential equation. For that, okay. So for that, we consider 1 by x equals to z. Okay. So if we differentiate this equation both sides, so it will be mm, minus 1 by x square dx dy equals to dz dy. Okay, because we are differentiate this equation with respect to y. Okay, so therefore this equation 1 become dz dy plus 2yz equals to minus y cube. So therefore the integrating factor will be e to the power integration 2y dy. So if we integrate this, it will be e to the power y square. Okay. So the general solution for this, for the given equation, given differential equation, it will be z into e to the power y square equals to integration q of y. So here q of y is minus y cube into integrating factor dy plus c plus c. So just have to integrate this. So it will be minus 1 by 2 e to the power y square minus 1. So just to integrate this function, you have to take another substitution, which is y square equals to, you can take as t, and using this substitution, you can easily integrate this function. Okay. So therefore, the required general solution will be z into e to the power y square equals to minus 1 by 2 e to the power y square into y square minus 1 plus c. Okay, and if we put the value of z here, it will be 1 by x equals to 1 by 2, 1 minus y square plus c into e to the power minus y square. Okay, so I hope this method is clear. Now try to apply this method to find the general solution of the given differential equation. Okay, so here the given differential equation is dy dx plus minus tan y divided by 1 minus x equals to e to the power x 1 plus x sec y. Okay, so here we can write this equation in the form of dy dx minus sin y by cos y into 1 by x plus 1 equals to e to the power x 1 plus x 1 by cos y. Okay, now we can also write this equation in the form of cos y dy dx minus sin y into 1 by x plus 1 equals to e to the power x 1 plus x. Okay, now here it's very clear that the derivative of this function is this. So if we consider that sin y equals to z and differentiate this equation with respect to x, so it will be cos y dy dx equals to dz dx. And if we put the value of cos y dy dx in the equation 1, so equation 1 will be dz dx minus 1 by 1 plus x into z equals to 1 plus x e to the power x. And this equation, we can say it's a linear equation in z. Okay, where this is our p function and this is our q function. Okay, now it's very easy to calculate the integrating factor. So here the integrating factor will be e to the power minus integration 1 by 1 plus x dx. Okay, so it will be minus log of 1 plus x, and it will be 1 by 1 plus x. So therefore, the general solution of the given differential equation will be z into integrating factor, means 1 by 1 plus x equals to integration qx. So here qx is 1 plus x into e to the power x into integrating factor. So it is 1 by 1 plus x dx plus c. Okay, so it will be cancel out e to the power x dx plus c. So it is e to the power x plus c. Okay, so therefore we can write this equation z equals to e to the power x plus c into x plus 1, where c being arbitrary constant. Okay, but here we substitute this value, means we take z equals to sine y. The given equation is in the form of xy. We take sine y equals to z. So here we have to put the value of z. So it will be sine y equals to e to the power x plus c x plus 1. This is our required general solution of the given differential equation. So I hope this method is clear. Okay. Now pause this video and try to find the general solution of this given differential equation. Here we can rewrite the given differential equation in this form. Okay. Now, if we consider z equals to 1 by log x and differentiate this equation with respect to x, so it will be minus 1 by log of y whole square 1 by y dy dx equals to dz dx. Okay. So therefore, the given differential equation will be dz dx plus y by x equals to 1 by x square. Now it's very easy to understand that integrating factor will be e to the power integration 1 by x dx, which is equals to x. Okay. So therefore, the general solution of the given differential equation will be z into integrating factor, means x equals to integration q of x, which is 1 by x square into x dx plus c. Okay, 1x will be cancelled out. So integration 1 by x dx plus c, this is equals to log of x plus c. Okay, and if we put the value of z here, so it will be x by log of y equals to log of x plus c. Okay, so our required general solution will be x equals to log x plus c into log y. Okay, we can modify this solution also. We can write this equation in the form of x by log x plus c equals to log y, and here the value of y will be e to the power x by log x plus c. So this is our required general solution of the given differential equation. Okay.